Good evening, students.
Good evening, sir.
Good evening, beta. Good evening, beta. So in the last class, I was discussing questions of de Broglie wavelength. Up to 5 question, up to 5th question I have discussed. Now go to question number 6. Next question, beta. Question number 6. Question number 6. An electron and a proton each have equal wavelength. Sorry, photon. An electron and a photon has equal wavelength of 2 angstrom, beta. So lambda is 2 angstrom. For electron lambda will be कितना होगा बेटा? It will be, this will be h upon p. ठीक है? This is for electron here. ठीक है? This is for electron. And if you are talking about photon, this will be lambda. ठीक है? Lambda is 2 angstrom for both. Is 2 angstrom. For both it is 2 angstrom. For the photon, energy is given by hc upon lambda. So he's talking about photon and electron and an electron. This is calculate their moment. So because corresponding lambda is, so what will be here? Okay, lambda is equal, so momentum here P will be h upon lambda. H upon lambda. For the photon also, what will be P? P will be h nu. H nu upon C. ठीक है? And this will be, and this C by nu, this will be lambda. So H upon lambda. For both, it will be same. So PE for electron, and this is for photon. So that will be equal. So PE equal to PH, and this will be H upon lambda. H upon lambda. ये कितना होगा? H upon lambda. Is it okay with everyone? बोलो बेटा.
Yes.
कितना होगा? 6.6 into 10 to the power minus 34.
3.3 into 10 to the power minus 24.
Yes, beta. So this will be lambda 2 angstrom 2 into 10 to the power minus 10. So this will be 3.3 10 to the power minus 24. Correct, beta? So this will be in kilogram meter per second. Kilogram meter per second. So this value will be same for electron as well as for the photon. Now, if you look at this photon, if you find out the energy of the photon, that will be hc upon lambda. They are providing us, this is 2 angstrom. Okay, so if I convert it into nanometer, then I can write here 1240 nanometer electron volt divided by, this will be 0.2 nanometer. So that is going to cancel out. ठीक है? This will be, तो कितना हो जाएगा बेटा? This will be one more zero will be there, and this will be 6 to, this will be 6, this will be 2, and 00 electron volt. This will be. Is it okay, beta? So this will be the energy of the photon. ठीक है, तो इतना होगा बेटा energy of the photon. Next is for the electron, what will be the E? E will be square root of P square C square, or I can write PC square plus M naught C square whole square. This will be PC. This will be P is H by lambda. ठीक है, so I am writing in place of P, I am writing H upon lambda. This will be C, so this will be HC upon lambda. ठीक है, so this is HC upon lambda square plus M naught C square whole square and square root of this. What is this hc upon lambda? You have calculated here. So if I convert this in electron in keV, this will be 6.2. ठीक है, 6.2 keV. ठीक है, 6.2 keV. So here you can write it 6.2 square of this plus this will be 0.51 MeV or 510 keV. 510 keV square. So the energy will be here in keV if you calculate it. So what will be this in terms of keV? बताइए बेटा कितना होगा? This will be roughly, बोलो. So try to understand. This is 510 square. This is 6.2 square, 36 only. And this will be very large. So roughly you can say it will be 510 keV. Roughly. This will be the energy of the electron. So this will be the energy of the electron. Here, photon energy will be this. This is the energy of the photon. Here, this is momenta associated with the electron and photon. This will be, so these are the answers of this question. Question number 6. Is it clear with everyone?
Yes.
Next question. Sorry. Question number 7. Question number 7. Find the kinetic energy of a proton. So what you have to find out? You want to find out the kinetic energy of the proton. This is our objective. Whose de Broglie wavelength is 1 Fermi. Lambda is how much? 1 Fermi. Or you can say 1 into 10 to the power minus 15 meter. This will be meter, which is roughly the proton diameter. And this m0 c square, rest mass energy of the proton, that is how much? 0.938. 0.93. This will be 0.938 GeV. ठीक है, try to understand. Sorry. 1 keV is 10 to the power 3 electron volt. If you are having 1 MeV is 10 to the power 3 keV or 10 to the power 6 electron volt. 1 GeV, ठीक है, 10 to the power 3 MeV or 10 to the power 9 electron volt. ठीक है ना? So remember this conversion. So what you want to find out? Kinetic energy. मुझे kinetic energy का पता करना है. So what will be the total energy of the proton first? That will be square root of p square c square or pc square you can write plus m0 c square whole square. Now p is h by lambda. P will be how much? H by lambda. So here this will be h divided by lambda multiplied by the c. So this will be plus m0 c square whole square. So if I write here, hc is how much? 1240 nanometer electron volt. ठीक है, divided by this lambda will be कितना दिया है? This. So if I want to convert this into कितना होगा बेटा ये?
10 to the power minus 6 nanometer.
10 to the power minus 6 nanometer. So this will be, you can write like this, 10 to the power minus 6 into 10 to the power minus 9. Okay, this is representing nanometer. So this will be 10 to the power minus 6 nanometer. So replace here 10 to the power minus 6 nanometer. So this will be cancelled out. Now what is this? This is, you can write in MEV or whatever is your choice. ठीक है, आप इसे किसी में भी convert कर सकते हो बेटा. ठीक है, you can convert it into any. बताइए कितना होगा. So here this is electron volt. Okay. So this will be okay. This is okay. This is square of this. Actually, I want to solve it as easy in easy way. I don't want to enter
It
into
will be
conversion of it.
1.55 GeV.
This is in, try to understand what I want to tell you. This is GeV square, but here this is electron volt square. So if you look at this 1240, if you take 10 to the power minus 6 in the numerator, this will be this. And if I write it 1.240, this is in electron volt. 240 and 10 to the power 9. ठीक है, this will be, so this will be equal to 1.24 GeV. ठीक है, 1.24 GeV. Substitute here square root of 1.24 GeV square plus 0.938 GeV square, and here it will be GeV. Now you calculate it. ठीक है, बताइए कितना होगा बेटा, बोलिए. What value you are going to get? This will be how much?
1.55
1.55 GeV.
Very good, beta. 1.55 GeV. This will be, what is this? This is total energy. ठीक है ना? This is the total energy of the electron. So what will be the kinetic energy? They are asking for kinetic energy. So that will be total energy of the proton. This is not electron. Please make it correct. Minus its rest mass energy. So this will be 1.55 GeV minus, this will be 0.938. 938 GeV. ठीक है, so in this way you can always find out the kinetic energy. कितना आएगा पॉइंट, कितना आएगा बेटा
616.
616 GeV. This will be your answer. So in this way you can find out, this is for proton, sorry beta, make it correct. This will be. Next question beta. Question number 8. Question number 8. The de Broglie wavelength of an electron in the Bohr orbit is estimated to be 1/5 of its radius. So de Broglie wavelength, they are saying it is 1/5 of its radius. Okay, so de Broglie wavelength of an electron in the Bohr orbit is estimated to be 1/5 of its radius. So I don't know they have not given me this is n equal to 1 orbit or n equal to 2 orbit or n equal to 3 orbit. So what can I do here? In place of R, I will Rn. ठीक है, Rn. ठीक है. Is this estimate correct? They are saying. They are saying, is this estimate correct? They are saying de Broglie wavelength associated with an electron is 1/5 of its radius. तो वो 1/5 of radius बोल रहे हैं. Is this estimate correct? We will think about it. So in place of lambda, what can we write? I can write h upon m Vn, ठीक है, और you can write this as h upon p or h upon mv, and this will be Rn upon 5. So mvn Rn, that will be equal to 5h. If I convert this into h cross, how much it will be? Divided by 2 pi, multiplied by 2 pi. So this will be 10 pi here, and multiplied by h upon 2 pi. So this will be h cross, or I can write h upon 2 pi itself. H upon 2 pi. And this will be mv. And what, according to third postulates of Bohr, ठीक है? So what is Bohr's third postulate? Bohr's third postulate. According to Bohr's third postulate, ठीक है, orbit this angular momentum mvr, ठीक है, mvn rn, ठीक है, angular momentum mvn rn, it should be an integer multiple of h upon 2 pi. ठीक है, so this n here, that is an integer. Integer means if with the electron revolving in any of the orbit, ठीक है, electron is revolving, so de Broglie wavelength associated with it, it should form a standing wave structure like this. And if this is a standing wave structure, then separation between two peaks, that will be lambda. ठीक है, so this will be lambda बेटा. तो कितना होगा बेटा ये 2 pi Rn. In the last class I also told you, if radius of this orbit is Rn, then the circumference 2 pi Rn, this will be, ठीक है, n times lambda. Only then standing wave type of structure is stationary wave type of structure will be formed. So in place of lambda, if I write h upon mvn, you can say 2 pi Rn. So this will be m via, and this will be h upon 2 pi. That will be. So this is known as quantization of angular momentum. This is, ठीक है, this is quantization of angular momentum beta. So if this condition is satisfied only, then there will be a Bohr orbit, ठीक है, which is possible. So here you should have an integer. So this should be integer. But whatever condition is given to us, what we are finding 10 pi, which is not an integer. And this is not an integer. This is not an integer beta. तो ये तो integer नहीं है. So that's why this condition, whatever statement is given to us, that is not possible. ठीक है, that is not correct or not possible. So whatever is statement is made, that is wrong. That is not possible. That is not possible beta. Next beta. Next question. Question number 9. Question number 9. Two particles A and B are in motion. If wavelength associated with the particle A is wavelength associated with the particle is how much? 5 into 10 to the power minus 8. 5 into 10 to the power minus 8 meter. ठीक है? Calculate the wavelength of the particle B. Lambda B you have to calculate. If its momentum is half that of A. So what they are saying, what condition they are saying, momentum of B associated with B is half of this momentum of A. This is, so what is P? P is H upon lambda B. Here it will be H upon lambda A and this will be 2. So H will cancel out and lambda B will be equal to 2 times lambda A. Lambda A. So this will be 2 into lambda is 5 into 10 to the power minus 8 meter. So this will be, you can say 1.0 into 10 to the power minus how much there? Minus 7 meter. This will be. So this is 10 to the power minus 7 meter is your answer. Next question, beta. Question number 10. Next question, question number 10. Question 10. Calculate the de Broglie wavelength of the neutron of energy 12.8 MeV. ठीक है? There is a neutron, ठीक है, whose energy is energy of the neutron that is given to me. That is how much? 12.8 MeV. 12.8 MeV. This is the energy that is given. Mass of neutron is 1.6755 into 10 to the power minus 27 kg. This is. So mass of the neutron is this much. You have to find out de Broglie wavelength. So try to understand. If you remember, rest mass energy of the neutron, this will be roughly 938 MeV. So if you look at the energy, this one, okay, this is quite less as compared to this m naught c square. Okay, so energy is this one. So what type of case is this? This is non-relativistic case. Okay, so non-relativistic case is there. Okay, non-relativistic. Even still you are having any doubt, you can do one thing. Okay, this is okay. Okay. So this is non-relativistic. Directly, this is quite large difference. Okay, this is quite large difference. Now, why this is 12.8 MeV? So one more thing I can say, if you that this En is square, that will be P square, yeah, PC square. What you are saying plus m naught c square whole square. ठीक है, if relativistic case is there, then this will be the case. ठीक है ना, this is going to be the case. So here this will be 938 MeV square. And on this side you are having, this is PC square. And here you are having this 12.8 MeV. Is it possible? This is not possible. ठीक है ना, this is not so. Here he is talking about non-relativistic case. So you can remove it. This was just to explain you. Now come back. So what will be the lambda? Lambda will be h upon square root of 2m E or kinetic energy. This will be in case of classical, in case of non-relativistic regime, this will be the total energy of the kinetic energy. ठीक है? This will be. So बताइए बेटा कितना होगा? This will be 6.6 into 10 to the power minus 34 divided by square root of 2 into mass is given 1.675 into 10 to the power minus 27 kg multiplied by energy. This is 12.8 into 10 to the power 6 joule. नहीं, 10 to the power 6, it will be in electron volt. Try to understand. First, I converted it into electron volt by multiplying this by 10 to the power 6 electron volt. Now convert it into joule. 1.6 into 10 to the power minus 19. Now it will be in joules. So try to understand. This is in MeV. First, I converted it into electron volt. So I multiply it by 10 to the power 6 and then convert it into joule by multiplying 1.6 into 10 to the power minus 19. Find out, Buddha, what will be the lambda you are going to get. बोलिए बेटा कितना आएगा?
8 into 10 raised to power minus 15 meter.
Correct, beta. So this will be 8 into 10 to the power minus 15 meter. So this will be 8 for me. This will be lambda, beta. This will be 8 for me. So option C is the correct answer. So option C is the correct answer. Next question, beta. Question number 11. Question number 11, beta. The de Broglie wavelength of a relativistic electron. ठीक है, we are having a relativistic electron. The de Broglie wavelength of a relativistic electron having energy 1 MeV. So energy E is 1 MeV. 1 MeV is the energy. Having energy 1 MeV is. So you are going to find out, ठीक है, de Broglie wavelength. Rest mass energy of the electron is 0.5. So what they are providing us, m naught c square. They are saying it is 0.5 MeV. ठीक है, it is actually 1.51 MeV, 0.51, but because they are providing me 0.5, so I'm going to use 0.5. So if something is given in the question, you have to use that parameter. ठीक है, so this will be de Broglie wavelength you want to find out. बताओ कैसे करोगे? This is a relativistic case. ठीक है, this is a relativistic case. One more thing, how can you check अगर if it is not given? So try to understand. Here I can show you directly. So this will be E square is equal to P square C square plus M naught C square. So this is 1 MeV square. I write 1 MeV square equal to P square C square. And this is plus 0.5 MeV square. So this is possible, beta. This is possible. So this is a relativistic case. Even they are not providing me, I can find out that this is a relativistic case. So from here you find out the value of P. PC first. So PC कितना होगा? How much MeV? This PC will be square root of 1 minus 0.25. ठीक है? So this will be square root of 0.75. So this will be 0.8 something. So 0.866. If you calculate it, this will be 0.866 MeV. This will be. So from here, what will be P? P will be equal to 0.866 MeV. by C. So what will be lambda? Lambda will be h upon p. H upon p. So h is 6.6 into 10 to the power minus 34. Here this p is 0.866 MeV. So 10 to the power 6 electron volt into 1.6 into 10 to the power minus 19 joule. This will be, now it will be in joule, and divided by C. So C will be here 3 into 10 to the power 8. You calculate this wavelength. Calculate this wavelength बेटा, कितना आएगा? This will be, बोलो. What will be this value? 1.43 into 10 to the power minus 12 meter. What do you call this 10 to the power minus 12 meter? बोलो बेटा.
Picometer.
1.4 picometer बेटा. This is picometer. This will be your answer. So this was question number 11. Next question, question number 12. Question number 12 बेटा. Consider a free electron, okay? One is the electron on one side.
Excuse me,
And
sir.
yes, beta, please.
Can you please share the previous slide?
Yes,
Since I
beta.
got the different answer.
Okay, beta, please.
I got 0.8 pictometer.
What?
Yeah.
Beta, check कर लेना. But whatever answer I have from my calculation, that was equal to 1.43 picometer. But please check. ठीक है, बाकी बच्चों का कितना आया? What you are getting, beta?
Same value, sir.
Same.
1.43.
1.4. तो एक बार आप चेक कर लेना बेटा. ठीक है, either you have written some number wrongly or something. Now go for the next. Consider a free electron and a photon. On one side it is electron, on another side this is photon. Photon. Both having 10 electron volt of energy. So energy of the electron is 10 electron volt. And here energy of this photon is equal to 10 electron volt. This is given to us. ठीक है? If lambda and p represents wavelength and momentum, then what will be? ठीक है? You are going to find out this. You have to find out the correlation between their wavelengths as well as in their momentum. So what will be lambda ph? ठीक है? I find out here lambda ph photon. कितना होगा? hc upon e. E. So this will be 1240. And this will be, ये क्या लिखा मैंने, E capital E, it should be capital E. Total energy, E photon. So here look, this is 10 electron volt. This will be in electron volt nanometer. So this electron volt will cancel out. This will be electron volt will cancel out. So it will be in nanometer, roughly 124 nanometer. Or you can say 1240 angstrom. This will be better. Now here, what will be this for electron? For electron, this will be this in electron volt. If energy is given in electron volt, then de Broglie wavelength for electron particularly, that will be 150 divided by V. Okay? So how many V are there? This will be 10 here. So this will be square root of 150 by 10. 10 angstrom. So what is lambda E? कितना होगा बेटा? Square root of 15. So this will be 3 point something. ठीक है? This will be 3 point something, 3.87 angstrom. 3.87 angstrom. So this lambda E, this is less, even quite less as compared to lambda of photon. ठीक है? So one of the relation is this. Lambda E is less than lambda photon. ठीक है? Lambda E is less than lambda photon. Now find out PE and pH. So ratio of PE by pH. I want to find out their relation. pH. This will be photon. ये कितना होगा बेटा? What will be H upon lambda E multiplied by pH? This will be also be H upon lambda pH. So this is going to cancel out. Lambda pH, this is 1240 angstrom. This is 3.87. So this is greater than 1. So PE will be greater than pH. वैसे भी lambda and P, they are inversely proportional. So even directly you can write. ठीक है? No need to solve this. If in the exam they are asking, you know that lambda and P, de Broglie wavelength and momentum, they are inversely proportional to each other. So what will be your answer? Option B. Option B will be the correct answer. Option B will be the correct answer. Next question, beta. Question number 13. For question number 13, we have not studied that formula, but many of you will be aware. So I will give the formula and then we will think. For a proton to capture an electron, so there is a proton, and what it do? It captures an electron. It captures an electron to form a neutron and neutrino. Neutron plus neutrino. ठीक है? Neutrino. Assumed massless. So mass of neutron, that is 0. ठीक है? The electron must have some minimum energy. In this case, the electron must have minimum energy. Okay. For such an electron, the de Broglie wavelength in picometer is. So, what will be the Q value for this? ठीक है? Q value for this. Find out. ठीक है? Q value आपको पता करना है. तो what it will be? Q value कितना होता है? बोलो बेटा. Mass of the, this will be, you can say, mass of reactants minus total mass of products multiplied by C square. ठीक है? So how much energy will be released in this process? Whatever mass is lost. So here I have used a very simple formula that energy released. ठीक है? This will be whatever mass is lost. Suppose delta m mass is lost. Multiply it by C square. ठीक है? Energy mass equivalence. If delta m mass will be lost, how much energy will be released? That will be delta mc square. So this will be the energy released. So what will be the mass of the, here? This is mass of proton plus mass of electron minus a mass of neutron. It will be into C square. C square. So it will be how much? बोलो बेटा. बोलिए कितना होगा बेटा? This will be, you should write in the way I'm writing so that you will be aware of it. MEC square, MEC square. Take minus common. This will be Mn minus MPC square. ठीक है, दिस इज 0.51 MeV. कितना होता है? 0.51 MeV. और ये वैल्यू कितना होता है? दैट इज 1.29 MeV. बोथ आर इन MeV. सो रिमेंबर दीज टू वैल्यूज. ठीक है, यू आर गोइंग टू रिमेंबर दीज टू वैल्यूज, दैट रेस्ट मास एनर्जी ऑफ द इलेक्ट्रॉन. ठीक है, फॉर इलेक्ट्रॉन इट इज 0.51 MeV. And difference mass of neutron minus mass of proton. Many times in nuclear physics you use this. In nuclear physics this number is very common, and this will be equal to 1.29 MeV. In first or second lecture, I think in second lecture we will introduce this number in nuclear physics. So you just remember it right now. So this will be, ठीक है, this will be, बोलिए बेटा कितना आएगा? माइनस 0.78 MeV. 0.78 MeV. This is Q value. ठीक है ना, this is Q value. So minimum kinetic energy required will be, कितना kinetic energy require होगा बेटा? बोलो. Minimum kinetic energy required here in this case, that will be minus Q. This will be minus Q. Actually, how we calculate this kinetic energy, try to understand minimum energy. ठीक है, minimum energy, ठीक, will be corresponding to when kinetic energy of these products, they are not carrying any kinetic energy after reaction, and this proton is also carrying zero. ठीक है ना, zero kinetic energy. ठीक है, or you can say proton is at rest. I assume proton is at rest, so its kinetic energy, because it is capturing electrons, so as compared to electron it is very heavy, so it is always advisable to consider it at rest. So if you consider their relative motion, ठीक है, so in their relative motion I can assume that proton is at rest and it is capturing electron. So here it will have kinetic energy, and I assume this is minimum kinetic energy that will be required. So kinetic energy of neutron and this neutrino, that will be zero. So what I am saying here, I write like this: proton plus, if you are finding it difficult to understand, so don't worry, this type of questions we will do in Q value problems in nuclear physics. So this will be neutron, and if you are having an idea, then this will be easy for you. It is at rest, no kinetic energy. I am assuming this is Ke minimum. When you are saying this will be minimum, so kinetic energy of neutron will be zero. Means just reaction is taking place, but these particles, they are carrying negligible energy. I'm saying nearly equal to zero, and I'm taking rough estimate. Q value, another formula of Q value is kinetic energy of the products minus kinetic energy of reactants. So product का kinetic energy कितना है? Kn plus K nu minus Kp minus Ke. This is zero. Try to understand. This is zero. This was at rest, so 0 minus Ke. This will be Q. So what will be the Ke? That will be minus Q. So minimum kinetic energy required. Okay, we are taking it as K minimum. So this is K minimum minus Q. So this will be equal to minus 0.78. That will be 0.78 MeV. Okay, this will be the kinetic energy. So this is the kinetic energy of the electron that is possessed by the electron, 0.78 MeV. Please note it down. This is just for your information. So this will be now corresponding to this value, we can find out the wavelength. We can find out the de Broglie wavelength. करिए बेटा जल्दी please. So 0.78 MeV. So they are saying, they are providing us that K is 0.78 MeV. Try to understand, this is greater than rest mass energy of the electron. So this is relativistic case. This is relativistic case. Relativistic case. So what will be total energy of the electron? This will be kinetic energy plus rest mass energy. 0.78 MeV plus 0.51 MeV. So total energy is, this will be 9. ठीक है, 9, 7 और 5, 12. So 1.29 MeV beta. This will be the total energy of the electron. ठीक है? So now use this equation, total energy of the electron. If you make the square of this, this will be P square C square plus M naught C square whole square. So this PC, that will be square root of E naught square minus M naught C square whole square. So this will be square root of 1.29 square minus 0.51 MeV square. This will be in MeV. So this will be PC. कितना वैल्यू होगा बेटा PC का? Calculate it. ठीक है, 0.51 स्क्वायर करोगे so it will be greater than 1.184. 1.184 MeV. MeV. So this P will be 1.184 MeV upon C. So what will be lambda? Lambda equal to H upon P. H is 6.6 into 10 to the power minus 34. Now divide this by P. Here, this is in MeV 1.184 multiplied by 10 to the power 6. Now it is in electron volt. Multiply by 1.6 into 10 to the power minus 19. This is in joule. And C will go to numerator 3 into 10 to the power 8. Calculate this wavelength बेटा. बताइए कितना होगा बेटा? Calculate this wavelength. This will be 1.04 into 10 to the power. देखना बेटा कितना आएगा. 10 power minus 12 आना चाहिए. पिकोमीटर में आएगा. 10 to the power minus 12 मीटर. अभी किया था ना एक क्वेश्चन इसी टाइप का. 1.04 picometer. This will be your answer. So these were the questions related to de Broglie wavelength I have. Now what you have to do, as I have told you earlier, okay, later on we will discuss. Okay, so for all the three topics, this is your homework. Compton scattering. This is the way of preparation. Photoelectric effect and de Broglie wavelength. Wave or wavelength. ठीक है, solve all the questions, ठीक है, which are asked from 2021 to 26. ठीक है, all PYQs. And wherever you are finding problems, ठीक है, send that question to me, I will discuss. So for today I am stopping here. Now I don't have much time to start new topic. In the next class we will start new topic, beta. Okay, beta, please save
Yes,
all these slides.
no.
Yes, beta.
So we don't
Yeah,
have your phone number, contact number.
I don't, you, okay. You can have my number 9899594283. This is my number, beta. 9899594283. Now please save all the slides. This is the first one. This is second. Third. This is third one. Fourth. Fifth. Sixth. Seven. Eight. Nine, beta. Yes, beta.
Sir, in 11th problem, we are asked to find the wavelength of relativistic particle.
एक minute, beta. This one. Yes, beta.
So we have formula for finding wavelength of relativistic particle. When to use that, sir?
देखो, this formula is common. ठीक है, this is a general formula, either relativistic or non-relativistic particle. But here for relativistic particle, this P will be relativistic momentum. ठीक है, if you are considering a relativistic particle, then this P is going to represent the relativistic momentum. कितना होता है relativistic momentum? P will be m naught v divided by square root of 1 minus v square by c square. ठीक है, so you need this one. So from where you are getting this? From this formula. ठीक है, in this formula this P is relativistic momentum. This P is relativistic momentum in this. So directly by using this formula, I find out P. So when I am calculating P from this formula, it means I am calculating relativistic momentum. So I use that, and this is the de Broglie wavelength for relativistic particle. Is it clear, beta?
Yes, sir. But yesterday we got a formula. Can we use that also, sir?
Which one? What was the formula?
Hc by square root of k into k plus 2m naught c square.
Actually, you use that formula if yes, you can use that formula. ठीक है, that formula. In that formula also I have used the relativistic formula, relativistic formulas of E. ठीक है, so I understood that formula. ठीक है, that was corresponding to relativistic particle, particularly for electron. So you can use that formula also.
But the k represents the energy, right? In that formula.
K is kinetic energy. ठीक है, K was, I was writing E. ठीक है, E was K plus m naught c square. ठीक है, so K was kinetic energy. So here this is total energy. So if you subtract m naught c square from this 1 MeV, then you are going to find out the kinetic energy. So K was kinetic energy, the relativistic kinetic energy. ठीक है, that was relativistic kinetic energy.
Yes, sir.
ठीक है, have you saved the slides, everyone?
Yes, sir.
Yes,
sir.
Okay, beta. Thank you, beta. Good night.
Thank you, sir.
thank you, sir.
Welcome, beta.
Thank you, sir.